The British Flag Theorem says that if we have some rectangle, later on we'll call the rectangle ABCD, but for now it's just some rectangle, and we place a point P on the interior of that rectangle. As we connect from corner to point P, what must be true is that if you square this distance and then this opposite distance here, that sum will be the same as the quadrants here, the square of that particular diagonal looking object, plus the square of this particular diagonal looking object. Here's how we prove it. The lengths we're interested in, again, are from the corners to P. And it gives us this thing that kind of looks like the start of the British flag, really to me looks more like an envelope. And then I'm going to draw in a couple other lengths. I'm going to go through the rectangle, up and down through point P, and then I'm going to do the same thing going side to side, again, making sure that this passes through point P. Hopefully you can tell that what we're creating are a bunch of different right triangles. I've got the one already drawn where AP is our hypotenuse. I've got another one here where DP is the hypotenuse, one over here where CP is the hypotenuse, and then finally I've got one over here where BP is the hypotenuse. Let's go back to those right triangles and think about them in turn. So for example, right now, the right triangle with AP as a hypotenuse. This length here is also W2. Everything in here is right angles, everything in here is rectangles. So we can say by Pythagorean theorem that AP squared is equal to W2 squared plus L1 squared. Now I'm going to go in here diagonally so that I can capture these other two lengths in a right triangle. That is, I want to capture the square of W1 plus the square of L2, which added together by Pythagorean theorem is going to make the square of CP. This means we now have two of our different lengths. We only need to figure out two more. Let's do that same thing with BP, for example, which is going to come from this right triangle, which has its legs W2 and L2, and so we can say that BP squared is equal to W2 squared plus L2 squared. And then finally, opposite that, we're going to figure out the square of DP, which is going to come from W1 squared plus L1 squared. So at this point, I have all four of those kind of diagonal-like objects, those lengths drawn from the corners of the rectangle to that point P in the middle. If we compare across these four different quantities, though, we'll notice something interesting. Each one of those partial lengths, W1, W2, L1, and L2, all have their squares represented exactly once on either side of this line. This is telling us that the sum of AP squared plus CP squared is the same as the sum for BP squared plus DP squared. This is the British Flag Theorem.